Hello folks, we are back with this exercise 5.6 and this is a part 3 video. The part 1 and part 2 video gave me a lot of challenge. Let's see now how the part 2 video is going to be. One second, I will have to check the connections. Yeah. The question number 7 is a voluminous question. So I plan to take only this one question in this part. So it says that x is sine cube t by root of cos 2t and y is cos cube t by root of cos 2t. As beginners it will take time. Now if we are experienced and by time maybe we will be able to do it very directly and very fast. But when we are beginners, in order to find the derivative it will take time. We have to make number of substitutions and then we have to do it. So since we treat ourselves as beginners, it will take us time to do this problem. So what we are going to do is to start with sine cube t we will assume as u, find the derivative, v we will take as a denominator, find the derivative, then apply the quotient rule, get dx by dt. Same way this we will call it as w and this is already v we have found out. So get their derivatives, then apply quotient rule, get the answers and then go for the parametric form equation and then get dy by dx. So that's long way to go. So let's start gradually one by one and let's see how we can do it. Let's start with x and we can see that x is cos sine cube t by cos root of cos 2t. So we'll, as I said, do it in 2 steps. Let u be sine cube t and v be root of cos 2t. So this you can see later. Now we will concentrate on this. Now here there are two functions, sin t raised to t. So sin t is also there, raised to t is also there. So we will make a substitution to make it a little more easier. So let maybe z be sin t. If z is sin t, then u will become z cube, sin t square, right? So with that in mind, let's get the derivative. Z is in terms of t, so dz by dt is going to be cos t. U is in terms of z, so du by dz is 3z squared. Like that, you can get du by dt, which we have to find. So, really stop writing halfway through. Okay, so du by dt is du by dz into dz by dt. So du by dz for us 3z squared and dz by dt is cos t, or rather z and all is our creation. Now we have to come back to what we know. So it is 3 sin squared t cos t. So you are up with du by dt only now. Okay, dv by dt also you should get, then only you get dx by dt. So also the v is root of cos 2t, same like this, right? Cos 2t raised to half. So let maybe w be cos 2t. So v will become root w. W in terms of t is, we know cos 2t is minus 2 sin 2t and dv by dw we know is 1 by 2 root v, nx raised to n minus 1 when we take the derivative. So let's have dv by dt. dv by dt we all know is dv by what? W. dv by dw into dw by dt. dv by dw we have it 1 by 2 root w and dw by dt we have it, it is minus 2 sin 2t. Okay, so let's revert back. W was our creation, so let's revert back. It is cos 2t. So minus sin 2t by root of cos 2t. So we are done with du by dt and dv by dt. Now it is for us to get dx by dt. So x is a quotient of u and v. So therefore x is equal to u by v. So therefore dx by dt will become v times du by dt minus u times dv by dt by v squared, right? So let's get them. V times du by dt is for us what? What is our du by dt? Yes, 3 sin squared. No, v we won't get. That's unfair. Let's come back to v. It's root of cos 2t. Root of cos 2t into 3 sine square t cos t, and u is what? Sine cube t. Sine cube t, and dw by dt it is dv by dt it is minus into minus sine 2t by root of cos 2t whole by v square, and v is root of cos 2t, so that is going to be just cos 2t. Okay, now equalizing. See, here the denominator is root of cos 2t, but here there is no denominator, so we'll equalize it. I think it will be more visible if you write it like this: sine cube t sine 2t by root of cos 2t. This is how the terms are more visible and more clear, right? So we'll have to equalize this. Here the denominator is 1, so if you multiply by root of cos 2t both in the numerator and denominator, we can have it equalized. So here we'll have root into root, it's going to be cos 2t 3 sine square t cos t plus sine cube t sine 2t by, automatically something divided by a fraction is multiplication by the reciprocal and all that. Because of that, this is divided by cos 2t, multiplication by the reciprocal, so it is root cos 2t into cos 2t. Okay, now many things to do over here. This will become cos 2t raised to 3 by 2, yeah, because it's raised to half raised to m, a raised to m half and 1, so a raised to m into a raised to n is a raised to n plus n. Like that, this will become cos 2t raised to 3 by 2. Now many things can come out common. We have to find out what is common. Like for example, this can be written as 2 sin t cos t. Cos we will not explore because it's like square and minus and all that, will create trouble. So, and from here therefore we will be able to get sin square t cos t common in both cases. Sin square t cos t, we can have it common. So what remains here? 3 cos 2t. And what remains here? Sin t and sin square t and cos t. So 2 sin square t and 2 sin square t is what is remaining. Sin 2t we dissolve it. That is what is remaining. So this is finally our dx by dt. Now we will move for y and try to get dy by dt. Now dy by dt also same way, you've got a numerator and a denominator. So we have to check out for the denominator is already there. We have to only check out for the numerator. We have let's see t, let for y let t be equal to cos cube t, right? And for r, we cannot have t, r, and z we have taken w. We can take it once again, but then let's take something else. S we can take, s be cos t, so r becomes s cube. So let's get the derivative. ds by dt is minus sin t, and dr by ds is 3s squared. Like that, your dr by dt will become dr by ds into ds by dt. That means 3s squared into minus sin t, or s means it is cos t. So 3 cos squared t minus and sin t. So dr by dt is done, but we want dy by dt. So y now is r by v for us. So dy by dt will become v into dr by dt minus r into dv by dt by v squared, like what we did before. So v for us is root of cos 2t, and dr by dt for us it is minus 3 cos squared t sin t, and r for us it is cos cube t, and dv by dt is that complicated thing. Where is that? This minus sin t minus sin 2t by root of cos 2t, and this is whole divided by cos 2t. Now again same way as we did there, we have to equalize cos 2t cos 2t. So it will become cos 2t times minus 3 cos squared t and sin t sorry, plus cos cube t sin 2t, we write it as 2 sin t cos 2. Sorry, and this will become cos 2t raised to 3 by 2 as we did before. So that allows us to take sin t cos square t out. So in the first bracket we are left with minus 3 cos 2t. Cos squared is out, so 2 cos square t is left. I'm so sorry. Raised to sorry. So we are done with dy by dt. So we are up for dy by dx. So how do we go in for dy by dx? Let's check. Therefore, dy by dx is dy by dt whole divided by dx by dt. All this we have with us. So let's see what is dy by dt for us. It is sin t. It is sin t cos square t times minus 3 cos 2t plus 2 cos square t by cos 2t raised to 3 by 2 whole upon, yeah, dx by dt. What is that? Sin square t into cos t times 3 cos 2t plus 2 sin square t by cos 2t raised to 3 by 2. We all know that when you have numerator, denominator by numerator, numerator can cut, denominator can cut. So like that, these both denominators can cut each other and go off, and we'll try to simplify this, or we'll try to also cut this. These also can be cut. One sin is left and one cos is left. So we are left with cos and sin. And here, right away at this step, we are going for substitutions of cos 2t depending on what we have here. Okay, so because we have a cos here, we'll get for the cos 2t substitution. Cos 2t, I'm not so good at the cos 2t, but it's derivable. So let me see what's a cos 2t in terms of cos. Cos squared minus sin squared, so cos squared minus 1 minus cos squared, so 1 minus, yeah, 1 plus, so 2 cos squared minus 1, and sin squared means cos squared minus 1 minus sin squared minus 1 minus 2 sin squared, yes. So it is 3 times 2 cos squared theta minus t minus 1 plus 2 cos squared t, and here it is 3, 1 minus 2 sin squared t plus 2 sin squared t. Let's expand this and see what's coming. So this is cos t by sin t. This is 6 cos squared t minus 3 plus yes, where is this minus on? Isn't it? Yes, we have to account for that. This is minus, and then this will become plus. Okay, then here it is 3 minus 6 sin squared t plus 2 sin squared t. Okay, so what is this coming? Cos t times minus 4 cos squared t plus 3, and sin t times minus 4 sin squared t plus 3. So okay, so what is coming? I have a dearth of 1 minus 7. That's what I'm searching. change this formula once again. Cos 2t is cos square t minus sin square t cos square t minus 1 minus cos square t. So it is 2 minus 2 cos square t minus 1. That's correct. And cos 1 minus 2. Let's get a height formula here. Alright. Yes, so this is coming out like now denominator is of course sin t into, it is like 3 sin t minus 4 sin cube t, which is sin 3t, and this is coming up as of now cos t into 3 minus 4 cos square t. That is where the problem is. There has to be a minus extra and that is not there, and yeah, so I will just sort it out. Yes, there is see, we have to leave the answer here, but then looks very, of course this is sin 3t, that's perfectly okay, this is sin 3t, but this doesn't fit into the formula of cos 3t, but for a minus, there is one minus which is creating trouble. So what we do is, we will kind of write it as minus cos t, and we introduce a minus inside also, so that it solves that problem. 4 cos square t minus 3, like that, without changing the value but getting it into the normal form. The advantage is this will become then cos 3t formula, and this is sin 3t. That's it. Actually, you could have stopped there, it was correct only. Was trying to get it into a cot 3t, minus cot 3t. Was trying to get it into a better form. Was just pondering as to how you could get it into a better form, and as such that answer was correct. But if you wanted the more specified form, that minus, that would be there. That's about it. It's a voluminous problem, though it's not very tough, but lots of steps. So that's how we do it. And now in the next video we come with the next problem. Thank you.